Hello everyone. So in this video I'll be showcasing the game engine that I made using C++ and OpenGL. So if you want to know what a game engine is, a game engine is a piece of software that helps you to create games. So each and every game that is available in the market has an engine that helped it to create it. Okay, so I have Blender running in the background. It is not a game engine, but it is a complex rendering engine. So rendering is also one of the core components of a game engine. So you can see how complex it is. It has all sorts of these things. Yeah, and it is rendering one of the assets that I will be rendering in my engine. So you can see how detailed it is, and it is, yes, lighting is calculated very accurately. So let me minimize it and run my application. So first of all, in the background all the meshes are being loaded. The meshes that I have defined in the constructor are being loaded at the runtime. So you can see it is being loaded, and I'm greeted with this. Okay, so let me explain each and every panels that I have. So first is the scene hierarchy panel. So this is, as if you seen Unreal Engine or Unity, each of those game engine has this hierarchy panel. This hierarchy panel helps to organize each and every entities that are present in the game engine. Okay, so what entities are? Entities are the different objects that I can add or remove. Okay, so every entity is a part of a scene. So like this is my scene, and all these are entities. Okay, so this entity has a name like square, and like those things, like square is its name. It has some transform. Okay, it has a camera component, sprite render component. So each and every entity in the scene has its component. Like what will be the name of that entity, it defines the behavior of that entity. Okay, so these are the game features that you need to have. Yes, so suppose this square has a color red. Okay, so I can choose a different model based on this selection that I have. So let's select a sphere. So this is a sphere with color red, and I have some material properties like how much rough is this sphere. As my engine is using physically based rendering, means light will be simulated as if light is hitting a real world object. Okay, with using the bunch of equations created by some people, you can easily implement PBR. Okay, so here's the roughness that defines how rough the material is. So if I decrease it, you can see the specular reflection of the sun. So if I change the direction of the sun, you can see that the reflection is also changing. Also you can see look at the frame rate. It is like 400 frames per second, so it is quite fast right now. It will degrade if I add more models, as you can see later. Next is the metallic. Metallic defines the property of the material. Is it metallic or non-metallic? So non-metallic objects are also called the dielectrics. So a material can have a value of 0 metallicness up to 1 metallicness, 0 or 1 binary like this. It cannot have half the metallic value because it is not defined in that way. So I can have full metallic value. As you can see, it is acting like a metal spherical ball. If I increase the roughness a little bit, you can see, yes. And if I compare it to a plasticky look ball, like I have entity and component entity, and if I convert it into a sphere and add, by the way, I can add components. As you can see, if I right click here, I can add components like transform component, sprite render component, camera component. I can also remove components, like if I want to remove this camera component, I can remove it by remove component and it's gone. So let's create a sprite render component. Sprite render component defines the properties of this entity, like what should be the color of it, what is the value of the metallic, what is the value of the metalness of this object, how much rough the material is, like these things. Okay, so yeah, if I make it red and if I bring it up here closer to it, and if I show you how much difference is there between a metallic and non-metallic thing. So if I change the roughness to 0.7, 0.6, let's see, so see the clear difference. Here the roughness of metallic is 0.6, here the roughness of a non-metallic or dielectric object is 0.6, and how much different they are. This has a plasticky look and this has a metallic look. Okay, so I can also add entities, like add create entity. It will create an entity. I can change its name. Let's give it a name, plant. Let's move it in the far z axis. And let's load the plant mesh and increase it. Okay. Rotate it. So here is a model that I've shown you in the Blender. Yeah, this model looks way more realistic in Blender, but as I'm approximating how the light will react with a physical object, so it is not that much accurate, but it gives the specular and the diffuse lighting correctly, kind of correctly. Yes, it is not at all correct, 100%. As you can see, the specular lighting changes as I change the direction of the sun. Yeah. I also have shadows implemented. The shadows are implemented using cascaded shadow maps. Yes, that is a shadow map technique that takes the image of the entire scene from the light, from the perspective of the light, and then renders the image into a depth map, Z buffer, and from that Z buffer means the buffer that has bunch of Z component values. Okay, so what I do is I take the scene Z components in the light projection, in the light's coordinate, not in the light projection, in the light's coordinate, and I compare the Z coordinates of each and every vertices of the scene that the scene has with that Z buffer. Okay, if it is lesser, then that mesh is in shadow. Okay, otherwise not. And for filtering, I am using percentage closure filtering, the PCF. Yes. So let me show you more models. I have a windmill model that will crush the frame rate. As you can see, the frame rate is 32. So it is destroying my frame rate, and this model is quite complicated and detailed. Let me scale it down. 3. I don't know why it is not uniform. I have to scale it non-uniformly, but that's okay. So as you can see, the windmill is also projecting a perfect shadow here, as I'm using cascaded shadow map, as you can so you can see that if I move further away, the resolution is getting degraded. Okay, and if I move closer, the resolution is getting increased. Okay, so this is the advantage of using cascaded shadow map. It's an advanced technique over the normal shadow map, and it saves a lot of memory. Okay, so now let's rotate this thing like this, and yeah, you can see it as. Also I have another model. Like what is the second square that I can okay, I have another model, the house. So let's load that thing. Yes, as you can see it is loaded, and let's add a sprite render component, and everything is okay. Let's rotate it 90 degree and move it along the x-axis a little bit. Yeah. So this is the house model that I created in Blender and loading it in my engine. So as you will see, the shadows are casted correctly. The railings are casting perfect shadows. The shade is also casting perfect shadow. If I move it like this, yeah, every shadow is being casted correctly. Yeah, also. My frame rate is being destroyed as I have pretty high quality meshes that I loaded. If I change this to metallic value, you can see. By the way, this model has no metallic map, so I'm missing a metallic map. So I don't have a metallic map for this model, so it is looking weird in some areas, like this bar of here. It should be metallic. If I change this property to metallic, then it is looking correct. Otherwise it is having a plasticky look. You can see here. Otherwise everything looks nice and correct. The text, by the way, the textures are 2K resolutions, because I want to save some GPU memory, so I didn't load any high quality textures, and the textures hold up quite good. Yeah. So last thing I want to show you guys is that I can add some point lights here. So here's a point light. So if I see, it is illuminating the scene. I can also change the color, like 0.3, 0.96. It is being illuminated, and the spheres are also capturing this reflection, as you can see. Yeah, also capturing this reflection. Let's decrease to 0.2. As you can see, the metallic sphere is capturing these reflections very easily. 0.2. You can clearly see the difference between the metallic and non-metallic object here. Let's add more lights and move it up like this, and move it in this direction, and make it 0.1 bluish color. You can see the house is being illuminated with a blue color. That's a blue tint, and the blue color. The number of lights that my engine supports is currently 100, because if you add more and more light, the performance will decrease, because it is iterating through each and every light and then calculating the PBR. Yes, the PBR calculations is being calculated per lights. If I have thousands of lights, then 1000 times the PBR calculations will be calculated. So it is expensive. It is expensive. So yeah. So let's close this. Apart from the things that are shown in the video, the engine has many more features. Like one of the main features of the engine is the scripting system, in which you could write a custom C++ script and then deploy it. Using scripting you can do many things, like you could control character using WASD keys, or you could change the color of an object. Many things can be done using scripting. Yes, the engine also has a real-time reflection system, but that system is in quite a rough shape, so I didn't show that. I am making this engine to learn about OpenGL and C++ in general. I have been making this engine for a year now, and I have learned many things. In the future I will be making a game using this engine. For that I am preparing my engine such that the game could be made easily. That's all. Thanks for watching.